Okay. All right. Well, I guess we'll get started here. Feel free to ask questions. I have tokens, and the tokens get you a free shirt. So many tokens here for many shirts if anyone wants them. So just a heads up there. But I'm Nick Kuhn. I'm a product marketing engineer with VMware Tanzu, and I'm going to be talking about building enterprise-ready chatbots with GenAI for Tanzu Platform for Cloud Foundry. That is a long title. Disclaimer here, I will be talking about some beta products, so just, everything's subject to change. Just take that with a grain of salt. But, we got to have the disclaimer here. And just a quick overview. We're going to be covering, I'm just going to do a real quick intro on GenAI and VMware Tanzu, and then we're going to deep dive into the GenAI for Tanzu Platform and get into some code and some live demos, and fingers crossed everything works, because I like to do live demos. But just some quick terminology here. Generative AI, hopefully you know what that is, but it's things like ChatGPT that are capable of generating text images. Basically everything under the sun now. Large language models, LLMs, power those generative AI systems. We have things called like RAG, or retrieval-augmented generation. That is essentially used to make these LLMs smarter and allow you to provide your own documents to do cool things with that, and basically expand the knowledge that's beyond its initial training set. And then part of RAG, there's this concept of called embeddings, which are essentially taking your document, translating it into numerical values, and then that's how the LLMs kind of transfer and learn off that. Now, a quick overview, what is Tanzu? So Tanzu is an application platform that's built and simplified for developers. It's optimized for VCF, and it's great for Spring. But really, I just wanted to kind of call out really quickly here, VMware Tanzu is a lot more than just like Kubernetes or Tanzu Kubernetes Grid. We have a full suite of many things. We have data services. We have multiple application runtimes based on Cloud Foundry and Kubernetes. We have Cloud Health. We have Tanzu Application Catalog powered by Bitnami. So we have many different pieces of this Tanzu suite overall that we have. And then also Spring is the largest Java framework that's under the Tanzu in many different ways. Now, to kind of deep dive in where we're kind of going into, if we're going to go down the lens of one of the application runtimes, so Tanzu Platform for Cloud Foundry, formerly Tanzu Application Service, formerly PCF, formerly Elastic Runtime, many names, but you all know what it is. It's based on the open source project Cloud Foundry, which is a platform as a service. You use applications. You can push your applications with something called build packs that kind of auto containerizes them for you. It's very modular in nature, where you can add additional tiles or services to the platform via marketplace construct. And it's a very modular and supported by a very robust infrastructure automation called Bosch. And I'll kind of go through this a little quicker here too. But just to give a quick highlight of what we see with Tanzu Platform for Cloud Foundry, we see massive scale and efficiency with the platform. We easily see platform engineer support, one platform engineer supporting up to 200 developers or more. CF push is that construct of that easy button for developers to go from source code to production. CF bind or service bindings in the marketplace allow developers to get services like a database or maybe even a large language model now into the service. And then we have a very good story around security. We're platform zero trust by default. We have basically a container mesh built into it. We have hardened stem cells, hardened OS images. It can repave or rebuild itself from a golden clean state. It can repair itself if needed, and rotate things like credentials and certificates, things of that nature. And really, the platform is really boiling down to this haiku: is here's my source code, run on the cloud for me. I don't care how. And that's really boils down to this concept of CF push, or deploying code to Tanzu Platform. And that's really focusing on minimizing that work. One command gets you all of these things ready to go. You don't have to worry about certificates, load balancers, servers, any of that stuff. Ready to go for you. But anyway, I know some of you are hardened PCF professionals, so I'm going to get into the meat and potatoes of this here. So let's introduce GenAI on VMware Tanzu Platform. So a year ago, I was here with Vegas and the Vegas VMware Code Explore Hackathon. And I had the privilege of running a team in the hackathon, and we actually got first place. Long Win, the lead engineer, he had an idea of trying to hook up this GenAI stuff to Cloud Foundry, and it seemed like it'd be a pretty good idea. A quick shout out, the hackathon's going on tonight, so if you have time and want to check it out, you should you should go by and cheer on the teams and maybe even see where you can help out. I know they'll have maybe some food and beverages too there, so don't miss that tonight. Unfortunately, I can't lead a team this year. I don't have the time, but I'm going to try to check it out and cheer on everybody doing that. And now we went from hackathon idea to a product. So GenAI and Tanzu Platform is available today. It's in public beta. If you're out there and want to join the beta program, happy to help you there. And what we're really doing here is we're really trying to make you the ability to quickly deploy large language models in your foundations really easy. So we use Bosch to deploy these large language models. We can support multiple inference engines like VLM or Llama. We support GPUs and CPUs. So if you have some NVIDIA GPUs, we can make use of those. Or if you have CPUs, we can do that as well. If you have VMware Private AI Foundation, we can broker into that as well. So we can support a mix of workloads, how you want to do that. But the main point of that is really getting your large language models hosted in a private manner. Obviously, a lot of people have concerns about putting data in these public models. You're not really sure what's going to happen to them after the fact. There's already been multiple examples of some of that data leaking out. And then also another kind of interesting, I guess, tidbit is that cost savings is becoming more and more of a thing, where these public models charge like by token. It's like a token's similar to a word. And if you ask questions to these models and it gives you back like a 1,000-line response, those are all just tokens adding up. And on a small scale, it may not be a lot of money, but we're finding in some use cases when we reach production level, it can become cost prohibitive. So that's another thing that we're actually seeing out of the beta program, is that becoming almost just as much as important as the private LLM functionality of it. And then we can load these models in the marketplace and allow developers to easily deploy them and bind them to their applications. I'll show this here very quickly here, but just wanted to give you a kind of high level of what's going on there. How does this work behind the scenes? So here's kind of like the architecture of the solution. You have your TPCF foundation, your Tanzu Platform foundation. You can deploy apps in the app runtime on Diego. Those can make calls to the tile via like an OpenAI endpoint or compatible endpoint. So a lot of these frameworks now support the OpenAI standard, and that doesn't mean like Sam Altman's OpenAI. It's just like a generic framework now or library that's based off that. And then we can use that to then call these private models. So this GenAI proxy will then route to our VLM models or Llama models, however we configure that. And then we can use things like the Postgres for a Tanzu Platform for Cloud Foundry tile to do PG vector embedding support. Or if you have Gemfire, Greenplum, they have some advanced analytics and data pipeline things you can do with that as well. So there's just a quick high-level view of what we're looking at. And then, of course, if you do have the VMware Private AI Foundation, if you have some of those very beefy GPUs available, we can wire it directly into that solution as well, and make the most use of your investment there too. So let's do a quick app architecture view real quick. So we'll see how many of these demos I can get through. This is about a 90-minute presentation. I'm trying to fit in 25 minutes, so I'm going a little fast. But we have this first app it's called Spring Metal. It's based off Spring Music. Some of you may have seen it before. But we're going to deploy a Spring application, Spring Boot application. It's going to have some SpringAI sprinkled into it to do some of this advanced functionality. And if you're not familiar with SpringAI is a framework to make these AI calls a little easier for your Java developers. We're going to wire into a Postgres database and use a database for albums and for embeddings. So you'll see that here in a second too as well. So there's a quick view of what we're going to dive into here. So let's see here, 10, 12, 10. So I'm just going to keep track of my time. Let me break out a PowerPoint, pause this. All right. Come on, computer. All right. All right. All right. So let's go to the marketplace here. So I've got the application manager for a TPCF here. I'm going to go into Spring Metal here. I've got a space. I don't have my app deployed yet, but if you go into services, I've already pre-created this the database I'm going to use just to save time. It takes about 5 or 6 minutes to spin up, and I didn't think I had that to go through here. But let's add a few more services here. So we want to add our new GenAI services here. So what's going on with this architecture? We need two model types. So we need a chat model, a model that's geared towards chat, and then we need a model that's geared towards embeddings. So I'm going to create this. I'm going to copy and paste this because that's better here. I'm going to select Llama 3.1. We'll do that. Select plan. I'm going to call it this here. So this is the giving the instance name, and I'm going to deploy this here. Click create. And then while that's going, I'm going to grab this other name here. Add service. We'll do this. And then I'm going to select this mini LM model right here. That's an embedding model. So not all LLMs are created equally. They are geared towards specific use cases. We'll click create. Go here. All right, so what's going on is I'm pre-provisioning these services. So when I push my app, they can just auto-bind and wire everything up, just to save time. But it's going to wire up this embedding LLM, this chat LLM, and this Postgres database. Let's go ahead and do that here. All right, let's see if this works. Live demo here, network. Okay, no apps found. All right, let's go for it. See a push. All right. If you haven't seen this before, service instance, MetalDB. I forgot to change this back. So it's got to match that name because I was doing testing earlier and didn't change that back. So let's try that again. It's clear. This is all live here. We'll do push. All my typos and everything. All right, so this is a CF push. It's gonna push up to the platform. It's just taking my code. I give it in a manifest file. That's just some simple wiring of what to do. But it's gonna upload my code to the platform. It's gonna fire up the build pack process. It's gonna say this is a Java application. It's gonna then wire up the Java build pack and do best practices like do memory mapping, certificates, and things of that nature. So that's we can see that Java build pack process kicking off now. So this will be done in a few seconds, and my app will be running, and everything's good to go there. But while that's cooking here, let's go into let's go look at this environment variables that we're getting out of these service bindings. So like the cool thing about this marketplace is that when you create these service bindings, it injects all these credentials into the application, and we have code in the application to automatically wire that up so that you don't have to really do anything on the developers just can simply consume these services without having to do a whole lot of infrastructure management, things of that nature. So let's go into this app, go in here and look at settings. We'll review the environment variables here. So we can see here we're getting our Postgres service on demand, like our JDBC connection strings, our name of our database. So that's just all wired up. Our app is just going to know how to talk and make these calls. Our password, username. This is all in a private environment, so you can't do anything with this anyway. But then here too, this is where the GenAI service comes into here. If you're doing development against like traditional, like the public models, you'll get like an API base and an API key, and then that'll essentially allow you to talk to that. So, but we are essentially running our own version of that GenAI proxy service and API and key. And then as we map additional models, they come in with different capabilities like chat. So this Llama 3.1 model I'm running has a chat capability. It also has an alias of GPT Turbo 3.5. So if you have older apps that aren't smart enough to toggle between different models on their framework, you can make an alias and do that. And then drill down into here too. Here's our embedding service, our base and API key, and then showing that's embedding in our model. So that's just how those all get wired into the application and they're ready to go. Let's see where our app is. This push, yeah, it finished, so that's good. So we can go back. Let's see here. All right, let's refresh. All right, so it's running, it's up, everything's good to go. All of our health checks look good. We can see that we're getting actuator, Java Spring Boot actuator data. Like our Postgres database is up and everything's good to go there. I could scale it up and down if I wanted to here, but I don't need to do that here. So let's go into this route. This is where I got my, I've got a URL, I've got certificates, load balancing, and everything's ready to go. I didn't have to do anything with ingress controllers or anything like that. Let's see, how does that look? Okay, so this is a simple application, but I can, in this version of Spring Music or Tanzu AI's Boneyard, it's all geared towards like Metallica and like heavy metal type of music. And I'm using Llama-3.1 and it's a little bit sassy, so you'll see that here later. But we can ask who produced the album VMware Explore 2024 Rocks. Oh boy, typing live. All right. So we're going to ask this question. It should not know about this album, VMware Explore 2024 Rocks, because obviously, that doesn't exist, and it's going to come back like, I'm sorry, I'm afraid, I don't know your question. This is not a Black Sabbath or Ozzy Osbourne or Metallica question, that type of thing. So let's go ahead and fix that. So when we can add an album on this application. Let me zoom out a little here. And then once this album is created, it gets stored as a regular album in the database, but it's also gets generated as an embedding to pass to large language model. So let's see here, Control V. No, all right, Spring VMware Explore 2024 Rocks. All right, so we're creating this album. We're going to call it Metallica. Genre DevOps. So Metallica is releasing a DevOps album. Nick really loves this. I'm going to do a user review. Nick really loves the song about GenAI for TPCF and a score of 100. I'll click OK. Let's do a sort on review. So we can see this. This album is here. It's produced by Metallica. Let's ask the question again. Do that again, and we'll see. Survey says. All right, I'm afraid I have some bad news for you. So you asked me about who produced this album, VMware Explore Rock. So it knows about this now. It's not a real Metallica album, so it's getting a little confused and interesting about that because it's kind of conflicting with its real data. So it's like, and also like earlier asked this, it was saying like Metallica doesn't do VMware Tanzu or DevOps. So I don't know why you're asking me this. So it's getting this data, and I should probably flip back to like not a Llama 3.1. It's like Llama 3 and Llama 3.1. Llama 3.1's a little bit more, kind of like fight back with you based on some of the prompts. But that's just an example of how you can pass these documents and do that. But I can go into more demos here. I still have a few more minutes, so let's do that. So the next demo I want to show you might be a little cooler. So we'll do this. We're going to go quickly look at Open Web UI. It is an open source Python project. It's pretty sweet, but it allows us to wire up a ton of models to it, and it gives us kind of like a chat GPT style interface. We can wire up the VMware Private AI Foundation as well. I'm working actually on moving the user database and doc store to Postgres and NFS. I don't have that yet. That's just in memory now, but you could do that and potentially even wire up the SSO servers to it as well. So let's get into that. Oh, and then really quickly here too, the code for some of the things work. We've got some additional code added on the SpringAI side and some of the CFE&V side to parse the GenAI service, and you can see where we're parsing these model capabilities and things of that to make that auto wire in so that developers don't have to worry about any of that. It's just detected in the bindings and good to go there. But that's off the SpringAI side. So now let's go to my other app here. Let's see here, GenAI samples, and we'll go to Open Web UI here. So we'll launch this. All right, and we might be able to do multiple. Let's delete this chat. Delete delete this chat as well. So a cool thing about this is you can upload documents to it. This is another, so we already have a document uploaded. So I actually made a document that's kind of like mimics my schedule. And I did a little thing on Twitter to like, and LinkedIn to show like how this works. But I can link this document. I can have a prompt too that helps save this too. So it's like you can prompt the model and says, I'm very busy at VMware Explorer Las Vegas. Please help me keep track of my schedule. Don't make up answers. It's really critical for some of these things. You need to tell them not to make up answers, and then answer in a friendly but brief style. So let's just do this really quickly here. Let's pick Llama 3.1 again. I'm opening a new prompt, so /. All right, so there's my prompt. I'm gonna pass it my prompt, and I'd be happy to help you keep track of it. Now, this is where I can then send this document. So you can see this could be really useful if you had like wanted to try to do your own style of this with like your own document source, things of that nature. So I'm gonna pass it my thing and say, tell me on Monday. All right, according to the schedule, ask me anything about that, 11:30. Anything else? How about the session I'm in right now? All right, yeah, here we go. All right, so then, yeah, so I'm presenting the session I'm doing right now, right here, 12 to 12:25, and then I have booth duty as well later tonight. So if you want to come check out the Tanzu booth as well, you can do that. Yeah, but you can see too, here's the actual citation of the document and things of that nature. So I just kind of like threw a bunch of random, kind of not really well formatted data in here, and it's just picking up off that pretty well. And then another use case that's pretty cool, you can do, let me do a new chat. Let's do the Llama model, and you can do like vision stuff as well. So let me upload a file here. Oh boy. Documents. All right, I found it. I thought I was going to get lost in my folder here. All right. Yeah, yeah. All right, tell me how many people are in this image. We'll see. Does it go through? No, it's processing. We'll see. Yeah, we'll see what it says, right? Now, this model hasn't been called in a while, so it's spinning up. Example, like a vision API or like vision model, where you potentially pass it things like a product SKU, or like what's this product, or things of that nature. And then one more thing, I can show that really quickly here. Let me just grab this. So I can do this, Command L, let's do a new. So if you haven't heard of continue.dev, what is this file doing? What does this file do? I don't know, that's probably not a great question, but let's see here. So this is actually, I'm wired up into one of those LLMs as well. It's actually a DeepSeek code LLM, and then you can have that actually source and read code and do kind of like that Copilot style, like autocomplete or highlight or tell you how to write code as well. So it's a pretty good example of this code as well. So that's just another use case of what's going on here. I have like 1 minute left. So if there's any questions, I have all these tokens I'm supposed to be giving away. So if I'll just give away the tokens. But yeah, so I think I'll wrap it up now and make sure we're clear. With this demo, it's all live. We're tentatively GAing for October. So it's still in beta right now. Oh, you get a token though. You asked a question.
So does yours count strawberry?
Strawberry? I don't know. We could ask it. Okay, question. Oh, like you could do that with like a data source. So like maybe if the app that's picking up, like you'd have a collector off the Kafka stream or something to Like, would you then like feed that to an embedding database? Or I don't know if I'm getting an echo, but yeah.
For a GPU or a CPU?
It both. Yeah. So I can even run this on like 9-year-old Broadbell based systems.
So